This is a video for homework 4, problem 7, also known as 10.2.9. And what they're asking you to do here is to use technology, probably the easiest way, to test a hypothesis using both the classical approach, which is with your z-scores, and what's called the p-value approach. So both of these can be done in StatCrunch pretty easily with the same nice little test here, okay? So first things first, you're going to have different values than I am. But that's okay, you can just fill in your values according to what you have in your problem. So we have here, we're going to go to question help and then to StatCrunch. We'll open up StatCrunch here. And what I'm going to do to run this hypothesis test, because it is regarding a proportion, it was the p-value, right? So if I look here, it was p equals 0.5, so that's the percentage is 0.5. We're going to go ahead and say stat, proportion stats, one sample with the summary. Okay, so going back here, we have some information that's given to us. So first of all, the hypothesis I'm testing is that H naught, my null hypothesis, is that P equals 50%, versus my alternative hypothesis, H sub 1, that P is less than 0.5. Now this symbol is going to be important, especially for the classical approach. So keep in mind whatever symbol they give you. They might give you a less than symbol, a greater than symbol, or a not equal to symbol. Then we have N, which is your sample size. That's how many people or whatever they tested. X is 66, which this is my number of successes. And then my alpha is 0.10. Now, this alpha equal 0.10 is going to be important even for the classical approach. We're going to do a little bit of an extra step with the classical approach to figure out what our rejection region is. Okay, so first of all, let's go back. So I have X is 66, N is 150, so I'm going to go back and put that in. So number of successes is 66, observations was 150. This is already set up for 0.5, and we just have to go ahead and change our symbol here. So mine was a less than, and I'm going to click compute. So if you look here, what's really nice is you actually have the things you need for both tests. You have your z-stat, which is used for your classical approach, and you have your p-value, which is used for your p-value approach. Now for the classical approach, we need to figure out, is this z-statistic in the rejection region? So we're going to have one more little step here to figure out what our rejection region is. Now, what I want you to remember, and I have my text out here so I can show you the pictures, here's how you determine your critical value, okay? If whatever alpha happens to be, okay, is going to be the area in the tails here, okay? So if we have a two-tailed test, meaning you have a not equal to symbol in your alternative hypothesis, the critical region is going to be both sides here. So if Z falls in either one of these little regions, we would reject the null hypothesis. In the left-tailed test, the critical region is going to be this little area to the left, and in a right-tailed test, it'll be the area to the right. Okay, so depending on which tail test it is, it's important because that's how you're going to fill out your values in StatCrunch to figure out what your rejection region actually is, what value bounds your rejection region. So let me go back here to, where am I think I'm here. Yes. Oh, gotta go back to StatCrunch. Here it is. Okay, so to do this, I'm going to press Stat. I am going to go to Calculators, and we are going to go to Normal. Okay, so again, alpha is the area in your region, your rejection region. So in this case, notice how already it has 0.5 shaded to the left. Okay, I like this to the left. This is what I'm doing because I have a left-tailed test. If I were doing a right-tailed test, I would change the symbol to the greater than. If I were doing a two-tailed test, I would go up and I would click this value right here between. Okay, but we are doing a left-tailed test, so I'm going to make sure that the area to the left is shaded. And I want the area in this shaded region to be whatever my alpha value was. Let me just go back here. I don't mean to make you dizzy. My alpha here is 0.10. So going back, I want my value, my area here, to be 0.10. And so therefore, the value that's going to bound my rejection region is negative 1.28. That means this value right here that determines whether I'm in the rejection region or not in the rejection region is negative 1.28. So then I'm going to take a look at my z-score that I had. Whoops, stay there for me. My z-score, my z-stat, was negative 1.47 approximately. right? Now we have to ask ourselves, is negative 1.47 in the rejection region? And because this is negative 1.28, negative 1.47 would be this way because it's a little bit bigger negative-wise, and it would be in the rejection region. So because it would fall in the rejection region, we would reject H naught. Okay, so going back to my problem here, we would say reject the null hypothesis. Okay, now next they want us to use the p-value approach. Now what's nice is you already calculated the p-value. So if I go back here, my p-value is 0.0708. So I need to round to 4 decimal places, which I already have, so 0.0708. Press enter. Now for your p-value approach, you're saying is p less than alpha. So the rhyme goes, if p is low, H naught must go, meaning if p is lower than alpha, you reject H naught. So is 0.0708 less than alpha, less than 0.10? 0.10, and yes it is. So since p is low, p is lower than alpha, we would reject the null hypothesis. Now they're trying to get you to compare these two approaches. There are times where using the classical approach you'll reject, whereas using the p-value approach you won't, and vice versa. But in this case, we get the exact same result both ways. So again, what you're going to have to do, if this symbol does change, you may have to change how you get your value that will determine your rejection region. If you have any trouble doing that, just let me know.